Okay, so a couple quick things with this Unit 1 retake practice. Like I said a minute ago, the average score was not terrible by any means. So this isn't some punitive thing that I'm telling you need to do every single problem in this packet. That would be crazy and psycho. If those of you watching on video could see, yeah, it'd be crazy of me to ask that. But here's what I want you to do. We're going to get you to have some skin in the game on this. I want you to look over your test. Now, for some of you, there may be some more pieces to this. For some of you, there may not be much of anything that you're looking at. But it still is some places you can find some, find some use out of this. So what I want you to do is I want you to look at your test and find some similar problems in the retake packet. So maybe your issue was, I don't know, fractional problems or piecewise or absolute value graphs, okay? Peek through the packet, find the ones that are similar, and circle some of them. You don't have to circle every single one, but some of them. Because those are the ones you're going to kind of get to play me for a minute. You're going to go through and say, ooh, here's my problem areas, here's the problems I need to practice to do this. So instead of you turning in a retake sheet, I'm going to have you do it this way. And then when you turn it in later, I can look and say, was this a good choice? Yes, 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 good. Because again, I get your test back in a little bit here, so you actually need to do this now and kind of be peeking through there a bit. Now, they're needed to do a retake. If you're coming to the retake, this is your ticket to be able to do the retake. Now, some of you out there are like, shoot, I got like an A on it, so do I need to do anything on this? Well, like I said, there's always places to improve. So maybe look at something where maybe you kind of paused for a minute, or maybe you look and you're like, no, I really do have this all down. If that's the case, then hey, you're good for today and we'll be starting the next unit tomorrow. But we're going to chat about this retake practice in just a second. I'm going to move this out of the way. And I'm going to take just a moment, and I will not be taking your tests back till a little later in the period. So, if need be, that's okay. But I wanted to talk to you for just a quick second about this other sheet that I had you pick up. I'd give these out at conferences, but I think there's a part of it that really can help you out with some of this too. Just kind of seeing where, everybody's piece is in all of this. So, I kind of say, so just to take a look at a second again to see what's up with this. Now, parents part, that's not anything you can do right now. But with yours and mine, just a couple of reminders again, okay? And I'm not going to read through every single one of these, either on my part or the student's part, but just a couple to highlight, okay? Again, because some of you asked me, well, when are you going to be here? Well, now you've got a sheet that can tell you, because I try to put it up on the sideboard too, just to help out with some of those things. On when to be able to help with some of that stuff, okay? Again, we know about the retakes. We've talked about reviews before, how they look just like the quizzes. And then the other one is either my YouTube page or my website, just to help you keep up with some things, especially if you miss something. Because some of you have missed the day before a quiz or a test, and then you come back and like, well, I didn't know. Well, but you do know. Because I talk about it for several days, and the video stuff's there. Missing that day before a quiz or test doesn't get you out of it. Okay? We've got to kind of keep up with that stuff. And then the other stuff is stuff I bark at you about all the time. Okay? Homework to reinforce. Yeah, I know. Check the homework. Oh, you mean I don't just have to do it? Well, no, we got to know if it's doing right. That's kind of important. Again, ask questions. If you don't want to do them in class, I was that way when I was in school, I'll admit it. Okay? But just sitting there doesn't help you. Sitting there reading, acting like the world's just passing you by, it'll fix itself. It won't. Okay? Go over the reviews. Yep. If it goes poorly, do the retake. Yep. Keep up with the missing work. Again, the folders are there. The website's there. I'm not chasing you down. We're 16, not 6. So that stuff needs to get taken care of. Paying attention, not talking to people like when I'm doing this, or reading books and stuff. That's not going to help you either. And again, got to play the catch-up game if you miss, just to make sure that we're back on track. Okay. But again, this is mainly just to give you those before and after school times, and just kind of remind you about some of that stuff that could help out as we move along in here. Now, back to the practice. So here's kind of our deal as we look through here. You're like, okay, we got equations. Oh, there's the lovely Algebra 2 F word. That's terrific. Not really, but I got to survive it. Okay. piecewise, yeah. So what I sort of thought my plan would be is I would go through where issues tend to be the largest and hit up on some of those. Now, if I'm not on a part that you're struggling with, work on a couple of those. I've got a key up front. You can check on a couple of those, but I'll make sure I hit on at least a little bit of everything to make sure that we don't leave some of you hanging here. Okay, so fractions are always seem to be not fun in here for some reason. So when I look at these, let's say for instance I look at 4 here. I look at 8 and 3 and 6. Now, if off the top of my head, I can't figure out the smallest number that multiplies to get all those. Okay, it's 24, by the way. But if I don't think of that, my other option would be to get this, oh no, not to move that. This back on the screen. Would be to take those numbers on the bottom, the denominators, and multiply them together. Now, you may not be thrilled at the beginning doing that because you're like, these numbers are going to be like ginormous. Well, that's okay. I have a calculator. So if I do it with the 144, again, this distributes through. And the deal is we take that number times the numerator, and if there's a negative, I'm going to put the negative with it. So 144 times negative 9. And then we divide by the number on the bottom, because that's really what a fraction is anyway. And I get that in there. And then I move to the next one, and I do the same thing. So notice, I can go through here and use the calculator to do this stuff for me. I don't have to be a mental math whiz kid to be able to do this right. Now I've got to remember the steps. That's kind of important. But otherwise, this is not, anything terrible. I got to make sure I do it to every term. Now, it doesn't look wonderful at this point, but at least I don't have any fractions left, which is kind of what the deal is here. Because some of you tried to deal with the fractions straight up, and it got kind of ugly. So something you might want to keep a little bit of a peek on. So I look and I go, okay, what can I do here? Well, those are like terms. So negative 192 minus 24. Because I don't do opposites, they're on the same side. And then since I'm multiplying p by negative 216, this isn't p minus 216. I don't want to add. Divide by that negative 216. And again, I don't have to be an expert. I just have to type it into the calculator. And I don't like decimals. Decimals not fun. So if you get a decimal, let's try math enter here. Okay. I can get fractions. Fractions are part of what we do. But again, if least common multiple isn't your strength, multiply them together. They're big numbers, but we just saw with the calculator, it's okay. It works. So I kind of got to see a couple of things there that might help me out with that. Now when I get down to the next part, this is where some things, again, all factoring, algebra 2 F word. Now again, you've got your help sheet to be able to go back to on this. And there's still a few of them sitting over there to the side. Where it might be helpful, actually, I'm going to keep yammering here and talk as I go grab one. So, when we're factoring, the biggest key to remember is that there's kind of a process with this like there is in anything else that we do. So move this up here towards the top, break out my sheet, and I go, okay, factor H, the golden rule. Do they have anything in common? That is always what I have to do first. I don't care if there's 2 terms, 3, 4, doesn't matter. Nothing divides into 16 and 25, and they both don't have an n, so I can't do anything with that. But then when I go, what size is my polynomial? It's 2 terms. There's 16n squared, there's 25, okay. Are they perfect squares? Oh, I don't know. Well, 16, 25. Oh, yeah, they are. Okay. Now, if I don't know what the square root of those are, if I don't know what to square to get 16 or to get 25, I'm not completely out of luck. There's a couple of things I could do. I could sit here and say, well, I don't know, should I try some numbers? Yeah, it didn't work. Okay. Oh, that one worked. Okay. That's one option I could have. Or I could just use the square root button. Like, where's that at? Square root button. A lot of the scientific calculators just have a square root button. This one doesn't. This one I got to do second and x squared to get the square root. And I could do it that way to get my number. But here's the key out of all of that. Now first, the example I have on my help sheet would kind of tell me. But if I don't have that or forgot about it, I'm trying to multiply to get a negative. And the only way I can do that's by doing 1 plus and 1 minus. And that's it. Now, does that mean every time I'm just going to be able to go to squares right away? No. Okay. Factoring has a lot of things that kind of move around. Okay. For instance, let's say we got to number 9. We're like, oh my gosh, this looks awful. So I start looking. Is there anything they all have in common? Well, sometimes even something that's small. Like for instance here, maybe I can divide all those by 2. Now if I can, it doesn't mean I just divide them by 2 and leave it that way. It means the 2 comes out front. Then you do all of your dividing. How many times does 2 go into 50? 25. How many times does 2 go into 80? 40. How many times does 2 go into 32? 16. And before some of you slide and divide here, we will talk about that a little bit during this kind of mini review. Here's what I want you to look for again. Just like we did up above with our perfect squares, if I look at the first and last terms of what's left, because I still have to factor this, I'm not quite done. If they're perfect squares, I can make this go really fast. So here's how this works. If they're both perfect squares, 16 and 25 definitely are, I get to this step, whatever I square to get the 25 part, I write that down. Whatever I square to get the 16 part, I write that down. And then whatever sign's in the middle, in this case plus, is what goes in there. And I want 2 of them. And we talked before about, no, the 40 hasn't disappeared. If I foiled this back out, if I did 5k plus 4, 5k plus 4, and I'll actually do that here for a second. If I were to multiply this out, and you don't have to do this when you do yours, but sometimes when you see where it comes from, it makes a little more sense. So if I multiply these together, and then combine like terms, 20 and 20, there's my 40k. I got it back, so this tells me I did it right. Now, could I slide and divide and get the right answer? Yes, but the numbers are going to be really big. And we're going to talk about the slide and divide again here momentarily. So that's one thing to kind of keep an eye on. Now, interval notation with our absolute value equations. I just want to look and make sure. Oh yeah, ooh, that looks kind of crazy. Let's flip over here because I want to find you a couple of things that I think could come in handy. We're going to do number 14. Now, a couple of things to remember on absolute value inequalities. One, I have to have my absolute value isolated before I split it up into 2, because I got to have 2 inequalities for this. So here, since I'm dividing by 8, we're going to multiply both sides by 8. So on the left, the 8's just cancel. And then 2 times 8 is 16. Now I need to make 2 inequalities. So I've got one here that I just leave everything alone. I never touch what's inside. Don't change things into positives. And then for my second one, I do 2 things. I flip the arrow. I change the sign of the answer. And once I do that, my job just becomes solving. Now again, if you get something and you get something decimally, I don't mind if you use the decimal. That's a little bit easier to graph. If you leave it as a fraction, that's okay too. And I got to do that for both of these. So again, I'm adding 2 to the other side. I want to avoid making silly mistakes. Let's see here. 7/8, 3.5, I believe. Now, the other thing we've talked about with these is trying to figure out, before I get to the interval notation part, and I can't forget that, is figuring out what this should look like. So when I see the greater than's an or statement. Ors typically have graphs that go out from each other. It gives me a little bit of a hint on if I'm doing this right. So I get to this, I'm like, all right, P is greater than, because the arrow is eating the P, P is greater than or equal to 4.5. So greater than goes to the right. P is less than or equal to negative 3.5. Again, if the arrow points at P, it's saying, P, you are less than I am. Less than negative 3.5. Equal to. And I see the graph looks like it's supposed to, so that hint helps me. And then the last part is, I've got to put it in interval notation. And the thing I got to stress to some of you is that's left to right. I can't put them in any order I want. So left to right means, woo, way off here to the left, negative infinity, until I get to my point here at negative 3.5. And then to say there's another piece, we use the U for union. And then we start up again. And off to the right forever. Most negative to most positive. Okay, gotta do the left to right thing. Can't switch the orders up. So absolute values. Make sure it's isolated. Split it into 2. Okay, I won't do anything too nasty to you on those. Graphing absolute value graphs. Okay? Absolute value graphs, when you graph them, well, they might open up or down, but they all should look like V's. Okay, I was seeing some of you would just giving me a line. It's not just a line. So before I try to graph this, and I can do part of this on the calculator, that's okay, and I'll show you how, but let's take a look for a second here. Do we remember what my shifts are? What this negative 3 and this negative 2 mean? When I'm doing what's inside, that's my left or right shift. And it's always the opposite of what I think, because the actual format for this looks like this. So it's the opposite of the number I see here. It's the opposite of negative 3, which would be right 3. And then on the end, that's always my up and down, and that's always whatever I see, because it's plus k. So it's going to be down 2. So how's that help me graph it? Well, it helps me in a lot of ways, actually. If I start at the origin and I go right 3 and down 2, that's going to be my vertex. So my vertex is at 3, negative 2. So I got the information by knowing how the shifts work. Once that got situated, and we'll zoom a little bit more here. I should have done this a little earlier. Once I get that situated, then I look at whatever the number in front is. Well, there's not 1 here. Well, in this case, then it's 1. That's my, remember, it's my air quote slope. Because it's positive, I know this opens up. So I go up 1 and right 1. But I also go up 1 and left 1. And if I want to do that a couple of times each direction, that's okay. But again, it should make a V shape. If it's a positive A, it opens up. If it's a negative A, it opens down. But the key is knowing your shifts. If you know your shifts, you're going to get your vertex right, and then the rest is pretty straightforward on that. Okay. And again, we're just trying to get you some practice. If we want to find some other things, we could go back. We could look at the unit review again. Quiz previews are great places to look to kind of see how some of this works. Okay. Now, I will mention there are some parts of this, when you start going through it, you're like, we didn't do that. Don't worry about those, because you guys and my honors class both got done with Unit 1 at the same time, so I stuck a few problems in here that might work for them, maybe don't work for you as much. Okay, standard form of the circle. Reminder on that. Actually, let's just do this, because I shouldn't have had that y there to begin with. And you're going to kind of see something familiar here. You're like, hey, there's that HK thing again. HK is my center. R is my radius. So when I'm asked to write the form of the circle, I'm already given all the info that I need. I have the H and K, and I have the radius. So all I have to do, x opposite of h, so minus 15, plus y opposite of negative 6 is plus 6, equals, now be careful here, it's radius squared. It's 2 squared, which is 4. That's all I have to do. Nothing else to solve, nothing else to do fancy, anything like that. So, that's all I'm doing on those. And if you wanted a challenge problem sometime, maybe you did really well in this part and you want to up it a little bit, you can see me about 21 or 22, and I can get you rolling with one of those as well. So, not a bad deal. Use the information provided to write the equation of the circle. Okay, so again, I need to know, to write the equation just like above, I need to know the center. I need to know the radius. Like, well, the center looks like it's right here. So the center this time looks like it's at 0, 0. The radius, how far from the center out to the edge, looks like it's 1. I can always get that information from my graph. And then I just go back up and plug it into the expression like we did up at the top of the page. So it's x opposite of h. We'll talk about the 0 thing here in a minute. Plus y opposite of k equals my radius squared. Now, can I leave it like this? Sure. Okay, if I wanted to just write it as x squared because the 0 doesn't do anything, could I do that? Sure. Okay, if you left it like this and had that equals 1, I'd absolutely take it. But if not, that's all right too. Now, the radicals we didn't play with in here. So that we're not going to worry about, but we are going to be seeing this. Ooh, do I want to give a little intro of this? I'm thinking I do. I'm going to. Let's do this. You're like, ooh, an intro to something we haven't even seen yet. All right. These actually work very similarly to the absolute value equations. They're not going to look like V's, though. So here's how this works. Still like it in here, this is still my left or right shift, still the opposite. So that just means it's going to be a shift of left 4. You're like, hey, this is like when we were doing the vertex thing before. It is. There's a lot of combinations with this. Now, this one, though, I don't have an air quote slope. This one, I'm going to get myself a little bit of help. There's ways to do it without the calculator, but let's keep life simple. If I go to y equals, we talked earlier about the square root button. It's second and x squared. And in this case, I'm going to type in my x plus 4. I'm going to close the parentheses up. So let's just look at the picture for a minute, and then we'll talk about how to use points here. Okay. So we get this point. Looks like it's starting like at -4, like this one is. If I hit second graph, my table, and I start scrolling up, after a while I see error, error, error. What's that mean? That means if I start sticking these numbers in, I'm going to get a negative number, and we can't take the square root of a negative number and put it on a graph. So you'll notice the very first number, -4 is 0. Hey, that's where I put my first point. That's why I need to know my shifts. After that, I just look for where there are whole number points. So like -3, 1. I don't want to do the decimals because that's kind of sloppy. 0, 2. And basically, I just go scrolling through to see how many points there are that are whole numbers. And then I just start there and connect the dots. And you notice that looks pretty similar to how this works. And that's all there is to square root graphs, okay, square root functions. They work very similarly in getting your first point and then just using the chart to get the rest of the answers. It's not a bad deal. And while we're at it, name the domain and range. Okay. My domain, my x values from left, we started at -4, to right, forever. Okay, arrows mean we're going to get infinity somewhere in this. My range, again, it's the y value at that point, which is 0. And that goes up forever. It looks like it levels off, but it doesn't. It just kind of keeps going and going. So you've learned something new before you've even had to see it. It's not a bad deal. Okay, that'll be coming. So if you want to try a couple of those, see if you've got it down. It's something new. Oh, let's see. You guys know I don't think we need to deal with these guys with you. This will be something that's coming up too a little bit later, but I see something more important coming on the horizon. You're like, Harty, more factoring, really? Yeah. Okay, where'd my half sheet go? Oh, there it is. All right. I'm going to do a couple in here. Only a couple. Well, yeah, only a couple. All right. So let's say I do 32. I go, nothing in common. Okay. 3 terms. There's nothing in front of my square chart. Use the diamond. Now, how does that work again? Oh, yeah. 2 numbers that multiply to get the number on the end, and add to get the number in the middle. But again, this is all about patterns. Well, what do you mean? Multiply to get a positive. I have 2 choices. 2 positives, 2 negatives. So how do I know? I look at this number. This says negative. Okay, these are both negative. So I need 2 numbers that multiply to 40 and add up to 13. Nice. Okay, if you know right off the top and can figure something out, that's great. If you can't, okay, write down the ones that you think of. Maybe you only think of 4 and 10 and 1 and 40, and you can't think of any other ones. Start using the calculator. Divide by 2, divide by 3 didn't work. 4, 5, and then you're like, ooh, 13. Okay, sweet. Now I've got this, but don't stop. Write them in there with the P and you're done, okay? Nothing terribly awful. But again, we got to go back sometimes and look to see, does everything have something in common? We talked about this on the front page. You get something like 34. You look and you're like, ooh, what do they have in common? Well, I see they both have an N. Okay, I can take that. Anything divided into 4 and 10? Two does. So I have to get both of them. I can't just take one. Once I get that out, now the game becomes, okay, what do I times this by to get this back? 2 times 5 gets me to 10. Got one N out here, but I need to get to 2, so I need one of those. 2 times 2 is 4, but I already have an N. I don't need any more. And this time I can't factor what's left over. Sometimes am I going to be able to factor what's left in here? Yeah. I'm going to have to look at that. If it says something squared, I probably am going to have to factor it. But that's how these work. And then finally, you knew one was coming. I said it would. Okay, we're going to do a slide and divide. Well, how do I know if it's slide and divide? Well, nothing divides into all 3 of these. So as soon as I see that there's a number left in front, that's when it's going to be slide and divide time. So, thank you. I multiply my 3 down to the end. Now this looks like a daunting task. Like, oh crap. So Harty, you want me to find 2 numbers that multiply to 210 and add up to 31. Yes. Now, Here's the nice thing. Everything's positive, so I don't have to play that game. I bust out my calculator, and I start dividing things in. And again, I'm looking for 2 to add up to 31. So, my God, let's see here. All right. We want to get out of the graph. So let's see, 210 divided by 3. Okay, let's see, 3 and 70. Yeah, those really aren't close yet. Maybe I need to start dividing by some bigger numbers. Let's try 5. 5 and 42. That's 47. That's still too big. 6. Whoops, that doesn't help when I don't hit the divide button now, does it? 6 and 35. Ooh, that's 41. Ooh, I'm getting close. Okay, I'm going to get this soon. I'm going to get this. 7 and 30. Oh, we're down to 37. Matter of time, matter of time. Oh, stupid decimal. Oh, wait, that ends in 0. Let's try 10. Ooh. 10 and 21. Those add up to 31. This works. Okay. Now, here's the key, though. So x plus 10 and plus 21. But I'm not done. This isn't slide. No. Slide and divide. So that 3 that I slid down before has to divide in. So I look, and I go, okay, if it goes in nice, 21 divided by 3 is 7. That's cool. Notice I don't put a 3 in front. I don't do anything fancy. Just divide it in. What if it doesn't divide in? Well, first make sure that it's as simplified as it gets. So 10 divided by 3. Ooh, I got a decimal. Well, math, enter, enter. Well, that's as simple as it gets. Okay. The 3, not in front of the parentheses, in front of the x. Whoops. And we're set. So again, factoring doesn't go away. It just keeps coming back in different forms. So we got to keep playing with it. Keep the factoring sheet available. Keep practicing. Keep working on them. Oh, another one of our favorites. Piecewise. Okay. Piecewise we've chatted about a lot, but we're going to chat about one more time here. And I'm going to start working my way through a little bit more quickly because I think there's one other thing we got to get to still. Okay. Here's the key. We start here. Both of our lines are starting at -2, no exceptions. If x is less than -2, okay, here's -2. Less than is left. So we're going to be using -2, -3, and -4 in the calculator. Whip up the calculator. Again, and there's calculators in here. You can get calculators for the phone, for the computer at home, like the one you got here. All that's on the front of my website. Use it, use it, use it. Okay, x plus 5. I just care about the chart. And I only care about these 3 values. So at -2, I'm at 1, 2, 3. Is that dot at -2, 3 going to be open or closed? Open, because it's not or equal to. And then I'm just going to plot the rest of these. Connect the dots. And I do that for each one. Again, greater than or equal to -2. Now I'm going to be moving to the right towards -1 and 0. But I still start at -2. Don't change stuff. -2x minus 1. Chart. All I care about are these 3 values. -2, 3. Hey, it's the same point. Except this time, closed because of the... So you're like, I'm going to close the dot that I had open? Yes. -1, 1. 0, -1. Connect the dots. That's how we do piecewise functions. Every time. You start at the point they give you, you work from it. Okay? And then if I ask you for values like this, these are just the x values. This works for one of these, and I'm only going to do one of these. F of 3, is 3 less than negative 2? No, that makes no sense. Is 3 greater than negative 2? Yes. So I plug the 3 in where the x is at and get an answer out. And that's all I'm asking you to do on any of these. Work through those, try that out, kind of see how it works. But again, the bigger part is actually doing the piecewise here. This is good to be able to do, but this is the critical point, folks. All right, I think we're getting near. Yep, good. Nearing the end, which is good because we're nearing the end of time here. All right, if domain and range is your issue, reminder. You start seeing arrows, infinity is going to be involved somehow. So like for instance here, my domain. Remember, it's the x values going from left to right. Well, if this is an arrow, this is going to keep going and going and going and going and going and going forever to the left, which is negative infinity. Negative infinity to the left, positive infinity to the right. So I keep going. Does it go forever to the right? No. There's a dot there. There's a dot at 5, so it stops. This can be mix and match. It doesn't have to be one or the other. My range is my y values. Okay. My y values that go from bottom to top. Well, going down forever. Okay. Does it go up forever? Nope. Now, again, don't use 5 again. It's y. It's range. It's going to be a 2. There's actually one other of these I want to look at with you because, well, no. I'm going to keep myself quiet on that. All right. And then we actually did absolute value already. I just stuck some extras of those in the back. Okay, so here's the deal. You've got, through the end of the week, if you're going to do a retake, to work through some of these. I'm going to be seeing what you did in comparison to the ones you missed on the test to see if we're ready to do a retake. And again, retakes are just on problems, types that you missed. You don't have to redo the whole thing. And we'll kind of work through that from there. Now, one thing